In the previous video, we answered the question, what is a distribution? Which we described as an approximation of a histogram of the data. In this video, we'll explore how we use our knowledge of distributions in fair lending. Specifically, we'll explain why understanding distributions is fundamental to understanding z-scores, p-values, and statistical significance. Suppose that we want to know whether a bank is discriminating against a protected class in the way it prices its loans. We commonly use regression analysis to answer this question, where price is our dependent variable, or what we commonly call the y variable, and an indicator for the protected class is one of our independent variables, what we call the x variables. So let's say we collect data from the bank in the first quarter of 2018 to estimate this relation. When we say estimate, in most cases this means that we are using the least squares estimator. In order to avoid getting too technical, let's just understand the least squares estimator as a mathematical formula that tells us the relation between protected class and the price of a loan. We often abbreviate this estimator with a lowercase b. Let's suppose that we run our regression and find that b equals 0.02. This result indicates that being a member of the protected class is associated with a higher price of 2 basis points on average. Ideally, we'd like to find that b equals 0, meaning that being a member of the protected class is not associated with a different price at all. But we know that our least squares estimator, or our formula, will return a different result for every sample that we collect. Remember, regression analysis is not a magic box, it's more similar to a calculator. And if we give it a different sample of data, it will return a different result. And with so many different possible results, how do we know if our result is statistically significant enough to conclude that the bank is discriminating? The answer to this question lies in understanding the concept of a distribution. We know that if we run many estimates over many different samples, the average of our result will be the true value. In statistical terminology, this means that the least squares estimator is unbiased, which means the results are normally distributed around the true value, which we call beta. So in theory, we could collect a large number of samples and rerun our estimator many times, and we could be confident that the average of our result will be the true relation between this protected class and the price. The problem with this is that we only have one sample from the first quarter of 2018, and therefore we only have one result, that b equals 0.02. And we want to know, is this result meaningful enough to conclude discrimination? In other words, is this result sufficient to conclude that the true relation between protected class and price, again which we call beta, is non-zero? Meaning that being a member of the protected class influences the price that an individual receives on a loan. Or is this result simply a random draw from a distribution where the true relation between protected class and price is actually 0, meaning being a member of a protected class doesn't affect the price at all? The distribution of the estimator helps us answer this question. The standard deviation of an estimator tells us how spread out a distribution is. When the standard deviation is 0.002, the distribution is relatively narrow. So, given this distribution, is it likely that beta is 0 and we just randomly drew a result of 0.02? The z-score and the p-value help us determine this. The z-score tells us how many standard deviations away from the mean our result is. So if the mean is 0, then our result of b equals 0.02 is 10 standard deviations away from the mean. The p-value tells us the probability of randomly selecting a z-score of 10 or more from this distribution if beta is in fact 0. And as you can see, the probability of doing this is essentially 0 because a z-score of 10 is very, very rare. This means that if our regression returns a result of b equals 0.02, then it is very unlikely that the true relation is in fact 0. In other words, our result is statistically significant, meaning that we have enough evidence to reject the hypothesis that beta equals 0 and conclude that the relation between price and protected class is non-zero. However, if the standard deviation of the estimator is 0.01, then this distribution is relatively wider. With a standard deviation of 0.01, the z-score is only 2 rather than 10. Is this a large enough z-score to conclude that beta is in fact non-zero? Well, the p-value tells us the probability of selecting a z-score of 2 or more, and the p-value in this case is 0.045, meaning there is less than a 5% chance that we will randomly return a result of b equals 0.02 if beta is actually 0. So, because the most common p-value cutoff is 0.05, we have enough evidence to conclude that, again, beta is non-zero. That is, there is a relation between protected class and price. And lastly, if we say the standard deviation is 0.02, then our distribution is even wider. And our result is only one standard deviation away from the mean, so our z-score is only 1. What is the probability that we draw a z-score of 1 or more? The p-value tells us that the probability is 31.7%. This means that it's very possible that beta is in fact 0, meaning there's no relation between protected class and price, and we just drew a random result of 0.02. In other words, there is not enough evidence to conclude that discrimination is occurring. Beta could very well in fact be 0, and we return this result. So in summary, the z-score tells us how many standard deviations away from the mean a number is. And in most cases, we use a mean of 0. So the z-score tells us how different our result is from 0. This is the z-score that's reported in SAS and Stata and other software programs that tell us how significant our result is. And the p-value helps us interpret this number by telling us the probability of randomly selecting a z-score of x or more. So the rule of thumb for determining if something is statistically significant or not is if the z-score is greater than 1.96 and the p-value is less than 0.05, then it is statistically significant. And given what we've learned in this video, if these things are true, then it is very unlikely that beta equals 0. That is, it is very unlikely that protected class and price are unrelated. Now the logical follow-up question to this is, how does this information about z-scores relate to t-scores? And for that, we suggest that you watch our next video in the series discussing the similarities and differences between t-scores and z-scores.